Hello and welcome to the beginning of Module 7. Today we're on Lesson 7.1, Ratios, Rates, Tables, and Graphs. You should know or remember that a ratio is a comparison of two quantities. A rate compares two quantities with different units of measure. We're going to be talking about these relationships today as represented in tables and graphs. So that we're working on this topic of how can you represent real world, yes, that means word problems, so real world problems involving ratios and rates and showing them in tables and graphs. And I will tell you that throughout the next at least 4 or 5 years of your math life, you will be working with tables and graphs. I'm in 6th grade in the morning. I help out in 8th grade in the afternoon, and my 8th graders we're constantly taking information and using tables and graphs. So this is an example of a table, okay? And a table shows us a variety of relationships or a variety of ratios. And it's important to know that all of the relationships in this table are going to be equivalent ratios at this grade level. So finding ratios from tables. Students in Mr. Webster's science class are doing an experiment that requires 250 milliliters of distilled water. So that's a number, 250 milliliters of distilled water for every 5 milliliters of ammonia. The table shows the amount of distilled water needed for various amounts of ammonia. Now, they've set up this table. So I know we've talked about whichever number we give you first is the first one. And this says 250 milliliters of distilled water to every 5 milliliters of ammonia. But you're going to always look at the table to see how they've set it up. In this case, they've put the ammonia on the top and the distilled water on the bottom. And you're going to see in a little bit, it's just a little bit easier for the math to do this. So they say here, use the numbers in the first column of the table. So even though they gave us in the problem these numbers, 5 and 250, they tell us in this problem to use the first column to write a ratio of distilled water to ammonia. So we could do this in 2 ways. We could do 100 is our distilled water in our first column to 2. We could do 100 colon 2. Or what we're going to use more of, what I'm going to use more of, and if you have me in classes or worked with me, I'd say I'm going to use the fraction form. And you'll see why as we go through more of these. How much distilled water is used for 1 milliliter of ammonia? So over here, we're going to want our distilled water. That's our distilled water to our ammonia. And we want ammonia to be equal to 1 milliliter. By the way, the rate for 1 is our unit rate we talked about. As we talked about in prior lessons. So I want to make that a little bit smaller. And so the reason I like setting this up as a fraction is now I'm just dividing. 100 divided by 2 is 50. So use your answer to write another ratio for distilled water to ammonia. I'm going to write the unit rate because I have 50. And that's equivalent to 1 unit of ammonia. If you need me to type that out, that's 50 units of distilled water to 1 unit of ammonia. And as I talked about at the very beginning of this video, I might have misspelled ammonia here. Let me fix that. I have students that'll correct that. But as I talked about at the beginning of this video, these are equivalent. When we use division, we're finding equivalent ratios. All of these ratios are equivalent. So let's look at our next page. So we just said the ratios in A and B are equivalent. How can you use your answer to find the amount of distilled water to be added given the amount of ammonia? So let's talk about this. Let's remember our unit rate is 50 units of distilled, if I could spell it would help, I know it's misspelled, water for 1 unit of ammonia. So for every 1 unit of ammonia, we need 50 units of distilled water. That also means that we could think about it this way. So 50 times the amount of ammonia would give us our amount of distilled water. So if I look over here, I could say if 2 times 50 would give me 100, 3 times 50 would give me 150. Which also means over here that 3.5, that would be our next one. Oops, what is happening there? Sorry, my pen isn't working. 3.5 times 50. So let's do that. 0 times 5 is 0. 0 times 3 is 0. 5 times 5 is 25. 5 times 3 is 15, plus 2 more is 17. So my answer here is 1750. Because I have 1 decimal point in the first number and none in the second, I'm going to put my decimal here. I'm going to type this so you can see it a little bit better. So this number would be 175. I'm going to erase all of this. Now, for the next one, I want some number times 50 would give me 200. That's going to be the same as 200 divided by 50. Let's practice long division. 50 does not go into 20. It does go into 200. I'm going to guess and check 4. The reason I'm going to guess and check 4 is because I know that 5 times 4 is 20. 0 times 4 is 0. 5 times 4 is 20. So 50 times 4 is 200. That means 4 times 50 is 200. When I subtract, I get no remainder. So that number is going to be 4. And then it tells us to look for a pattern. When the amount of ammonia increases by 1 milliliter, we kind of talked about this up here, the amount of distilled water increases by 50. So we're multiplying the amount of ammonia by the amount of distilled water. So 6 milliliters, we would still multiply by 50. I'm going to put my 50 on the top because it's larger than 6. And when I multiply, it can multiply numbers in any order. 0 times 6 is 0. 5 times 6 is 30. So for this one, I would need 300 milliliters of distilled water. So we're going to go through this next. Oh, this is filling more of this in. So copy the table that we got. So let's see here. So we remember 3 was 150. 3.5 was 175. This 200, 4 went up here. So we have our table filled out. Write the information in the table as ordered pairs. So the number on top in this is our X value, and the number on the bottom is Y. And if you're not sure which is X and which is Y, look at the examples here. They told me that 2 here is the X. So that means, let me do the text boxes so they're easier for you. That's going to be 100. And then 3 is going to go with 150. 3.5 is going to go with 175. 4 will go with the 200. And 5 will go with 250. Now they've asked me to graph the ordered pairs because fractions and decimals can represent amounts of chemicals connect the points. So in the future, I'm going to get better copies here for you, but this is the X value is 2 and the Y value is 100. So I'm going to put a dot right there. 3 is going to go with 150. It would be right there. 4 is halfway, is going to go, sorry, 4 is going to go with 175, which is halfway between where I made that dot for 150 and where 200 would be. Sorry, I messed that up. That would be 3.5. So let's see, 3 would have been here. 3.5 is halfway between 3 and 4. 175 on the y-axis is halfway between 150 and 200. And if you're not sure how I'm graphing these points, then you want to take a moment when this video is over and you want to talk with your teacher and make sure you understand. Because fractions and decimals can represent amounts of chemicals, we're going to draw a line. And basically what you should see is all of these should connect. And we should have, go back here, kind of hard to see, you should have an arrow here. There doesn't need to be an arrow there. So describe the graph, what we want you to see here. It makes a straight line. And by the way, this will be important later. I'm just going to enrich you here. Enrichment means teach you something that you'll need in a prior lesson. I would point out it makes a straight line, and the line goes through 0, 0. You don't really need that yet, but I'm going to teach you some 7th grade math. You're going to get extra smarticle. For each ordered pair you graphed, write the ratio of the y coordinate to the x coordinate. So that means the y coordinate was 100, and I want it over, I'm going to have to write this, and it's hard to see my writing. So 100 over 2. 150 over 3. 175. I know I'm moving slow, but I expect you to be writing this 3.5. When your teacher checks, you should have all of this filled out. 200 over 4. And this would have been neater, but I'm running out of room here. 250 over 5. So the ratio of distilled water in all of these could be simplified to 50 over 1. How are the ratios related to this ratio? I want you to have all of the ratios could be simplified to 50 over 1, which means they are all equivalent ratios. And now you could fill this out, the division of water. How are the ratios related? It didn't copy. So that's what I would want you to have here. All of the ratios could be simplified to 50. They are all equivalent. Let's do that. Control C. Okay. The point 2.5, 125 is on the graph, but not on the table. The ratio of the y-coordinate is to the x-coordinate. So if we wrote that same ratio, it's 125 to 2.5. And if you simplified this, you would still get the ratio of 50 to 1. And if you don't believe me, I'm going to do it right now, but you can take your time and you can actually do this division problem. You could do 125 divided by 2.5. Okay? So 2.5 milliliters of ammonia requires 125 milliliters of distilled water. What do you think is true for every point on the graph? I want you to get for every point on the graph, if you set it up as a ratio with y over x, you would be able to simplify it to 50 over 1. And they are all equivalent ratios. So how could you use the graph to find the amount of distilled water for use in 4.5 milliliters of ammonia? Well, let's look at the graph. It's hard to see. I will get them flatter, but if you went right here, that's about where 4.5 is, and went up, you would see, so that would be 250, that it would be a little bit less than 250. So let's type that. Let's write that. Let's make sure we understand that. If you found the 4 value on your x coordinate and looked and followed that up to where you intersect the line of the graph you drew, you would see that they intersect at a little less than 250. And you need to be able to do that. You need to be able to look at a graph and connect the line up. And if you're struggling with this, or if there's too many lines and you're like, which line am I looking at? That's something you definitely want to ask the teacher to meet with you and go through. At this point, the teacher could decide if you feel like you got it, you could pause the video and have the students go through these on their own and then watch the video. That would be one thing you could do and see if they got it right. but I'm going to go ahead and then do this problem. But again, if you want the class to try these, stop the video and then restart it. They can check their work. So you can use tables and graphs to represent real-world problems involving equivalent rates. And we're going to do this problem with a table here, problem A, and then B with a graph. The Webster family, so what I'm going to do is I'm actually going to move this out of the way for a second. The Webster family is taking an express train to Washington, D.C. The train travels at a constant speed and makes the trip in 2 hours. They're going to help you here. Make a table, and what they've said is it makes a trip in 2 hours. So the total distance, I think it says it, it's hard to see, is 120 miles. And this is 2 hours. If we divide, we're going to get a unit rate of 60. That means 60 miles in 1 hour. Now, they've gone back and they've changed the distance, the time is our x value, and the distance is our y value. So 2 hours, 120 miles. If they traveled somewhere for 3 hours at this same rate, they would go 180 miles. They're getting that because each time, you can look at this 2 ways. They're taking the x value and multiplying by 60 to get the y value. So the arrow I have going like this. 2 times 60 is 120. You could also look at is you take the y value and you divide by 60, and you would get 5. So they've filled out this table. For the next part, they've told us to write the ordered pairs, and they've done that. So writing the ordered pairs meant, okay, so here we're going to have 2, 120. 3, 180, etc., etc., etc. And then they've gone ahead and graphed this. And if you are struggling with how to graph these, I'm going to tell you, you need to ask your teacher to help you. If you see me around school and you don't know how to graph these points, even if I don't know you, I am Mrs. Fogg, stop me and ask me, because you are going to need to be graphing these points for the next 4 to 5 years at least of your math career. So they did 2, 120 first. So 2 is the x value. I'm going to find 2. It's right there. I'm going to find 120. And I'm going to take my 2 fingers and I'm going to go to where they meet. This blue line that is here is the line that represents your answers. This blue line is placed there after you place the points. So they wanted 3, do a different color here, 3 and 180. And when those intersect, those lines meet are right there. So after you plot those points, then, I want to get a line tool here, then you would draw the line that connects them. And there is an arrow on this line. It goes on basically forever, this relationship. And that is what you need to be able to do. So for the next part of this, you're going to have some practice where you're going to try and create these on your own. If you are struggling with any part of this, please do not ignore it. Ask your teacher, ask somebody for help, find me in the hallway before lunch, because this is something that you are going to need to be doing for the next 4 to 5 years in math. I know this video went a little bit longer than I intended. I want to thank you for all of your time.